Hello and welcome back to Mr. Lamb's Science Corner. We're talking today about three related videos, all talking about the total eclipse of the sun, which is going to be August 21st. So it's coming right up. As I mentioned in the first video, there's two basic methods for safely observing the total eclipse. One is indirect methods, and then another is, of course, then direct methods. And in the indirect methods, we talked about the pinhole camera and showed how very easy that is. So you just need two pieces of paper, one with a very tiny hole poked in it. The other one, indirect method, is a little more complicated. And it's called a mirror. I call it a mirror image because we do use a mirror. And I'm not really sure exactly how necessary it is, but I like to mask off most of a mirror. Okay, because at times you will get the image of the mirror instead of the sun. So I draw a roughly circular thing in here, and the mirror, I've used some very cheap mirrors. This happens to be one from the Dollar Tree, so it set me back an entire $1. So one thing, if you've been following this series, you know that I'm cheap. So we'll use this in a bit. The advantage to the mirror image is you can get really a fairly large image, large enough to where you can actually, if you're lucky enough, you can actually see images of sunspots and things like that. I've gotten an image, roughly a meter or thereabouts in size. Which is really good size, but you need a lot of room and you need a wall that is in some kind of shade. So there's limitations. The nice thing about this is that even if there's not an eclipse going on, you can do this, and I'll show you how to do a math exercise. So that you can get math and science into this. The eclipse is, of course, you can get a lot of publicity is surrounding eclipses, even partial eclipses, and so there's a lot of interest drawn in that. But you tell the kids, hey kids, we're going to go out and look at the sun in a safe way, and we're going to, and then we're going to measure how big the sun is, because you could ask the question, how big do you think the sun is? It's a little thing up there in the sky, and you tell them it's huge, but this would be a chance to actually do that calculation. And the basic process is quite simple. Zoom in here on this. You have the sun up here, and you're going to get light from the entire disk, and it's going to come down essentially to a point at your mirror, and then the mirror is going to reflect that onto the wall and make an image. And so you can get this set up if you can figure out a way to set the mirror into place with sandbags or popcorn bags or something. You can then go over here and look at a close-up of the mirror image and see what there is to see. And as if you're lucky to be in a place where you have a total eclipse, you'll see big chunks taken out of the sun until it completely disappears, and then of course there's no reflection, and then you can come back with the thing. So if you're going to do a math problem and actually calculate the diameter of the sun, you're going to have a proportion here. If you have the distance to the wall is A, and the size of the reflection is B, and the distance from the Earth to the sun is C, and then the diameter, of course, is D. And if you do that, if you look at this, hopefully I get this right the first time, you have a proportion. So fifth graders, I know, they see proportions, and maybe earlier. Quite frankly, I'm not all that conversant with what happens in elementary school. My expertise is high school chemistry and other related sciences, and to a little bit high school math. So anyway, you have A over B is equal to C over D. Okay? So we have the simple proportion A over B equals C over D. And if I'm just going to make some numbers up. But show you how the numbers go in. So A is the distance from the mirror to the wall. So that needs to be a fair distance. So I'm going to write up here again, A over B equals C over D. And A could be something like 30 meters. Now, if you want to go yards or feet or something like that, that works. Okay, not a problem. But most of the time we want to do metric. Okay, so 30 meters, and if you do that, you'll get a B, which again is this size here. Let's say you get something like 0.75 meters. And again, like I said, I'm just making numbers up, just to give you the idea of kind of the range of the have. Now, you can, since meters over meters cancel to no units, we can have, as long as they're the same unit top and bottom, we can have the same units here that are different than the meters. In other words, we measure in meters here because it's convenient for us, but it may not be convenient to write down how many meters it is to the sun because there's a lot of them. Okay? And I probably should have figured this out ahead of time and all like this, but I'm going to go old-fashioned because I'm old, and I'm going to say that the sun is 93 million, I'm running out of room here, miles, because that's the number that I grew up with. Okay, and again, the meters here will cancel, and so if I write this one here, which is the width of the sun in miles, then those two units will cancel out as well. And so I'm going to write that this is still my unknown D. So if I look back here at the math, then D, if I do the math here, I get A times D equals C times V. Okay, so I just cross multiply. And I'm going through this slowly because I'm trying to explain this not only for elementary teachers, but also hopefully there will be some homeschool parents who are looking at this and saying, yeah, I can do that, but it's quite likely that they haven't done a proportion for some time. So I'm not, I never want to be thought of as talking down to anybody, because I'm not, I'm really not. But I'm just saying that if you ask me to do something in English, like split an infinitive or dangle a participle or something like that, I'm going to look at you like, I know those words, but I have no idea what they actually are, because I haven't used them for such a long time. So I'm going to work through fairly thoroughly, I guess I would say, in case we have some people watching who want to do this, but are a little shaky in remembering all the stuff about math. So please understand, I'm doing that out of respect and not out of anything else, because I really want everybody to participate and want to get in there, and I don't want math to be a reason to say, no, we don't want to do that. Okay? So anyway, so you cross multiply A times D equals B times C. Okay? And then, and I could do this in one step, but I'm going to do it in two here. I'm going to divide by A so I can get D by itself. And what I wind up with is D equals C times B over A. Okay? So D equals C times B over A. And if I work this out correctly, hopefully, if we do the calculations, we will see that D is going to be, and I'll go ahead and give you the number. You can get an exact number from Google, but it's about 800,000 miles across, which makes the sun a very, very large object as far as us. But as far as stars go, it's on the smallish side. In that there are plenty of stars that are smaller than the sun, and there's maybe not so many that are larger than the sun. But in terms of what's possible from the largest to the smallest, it's called a yellow dwarf, but it happens to be brighter than more than half the stars. So anyway, how big do stars get? There are stars out there that if you put it into our solar system, they would be, the Earth would be kind of at the surface of the star. So that would make them with a radius of 93 million miles. So very, very large. How small can they get? There are neutron stars out there that are about 10 miles in diameter. But they have the whole mass. So the density of a neutron star is incredible. It causes some very severe problems in terms of gravity. So anyway, a reminder that when we are outside, the wind is blowing today, and that means we probably won't be able to get any sound, because all you get is the sound of the wind, and that's not going to work out too well. So we probably will have the sound turned off. Okay. Welcome to Mr. Lamb Science Corner. Well, we were able to see the setup for the mirror. I'm sorry that there was no sound, but we've tried this before, going outside, and if any wind is blowing, which there was, it just makes it hard to hear. So tried to mime it a little bit, and I'll let you judge whether I was successful or not. Hopefully was. We have two similar triangles. We have the triangle formed, excuse me, by the image, okay, and then we have the triangle formed by the sun and the length of the distance from here to there. And in that they're similar, we can set up, if this is the mirror, and that's B, and that's A, and D, and C. These are arbitrary. You can go whichever way you want. I like it because you can write this equation, this proportion, and you get A over B equals C over D, and that just seems to be kind of a nice way to write it. But again, it's just arbitrary, so you have to look to see that in this case the image over the distance along the ground is equal to the size of the sun over the distance to the sun. So you have to get them in the right deal. If you screw this up, you'll get a very bad answer, trust me. And there's, I think, 12 different ways of writing this proportion. 6 are right, 6 are wrong. So if you go by image, distance, sort of image, distance, then you'll hopefully do right. If you then take and realize that you're looking for C, the distance, or excuse me, the diameter of the sun, then you have the equation. You have A is the image of the sun, and you have D, which is the distance to the sun, which everybody hopefully knows is 93 million miles. You can figure that out in metric if you wish. And then B is the distance from the mirror to the wall. And if you work it all out, you'll get a reasonably accurate number. When I did this with students, we normally would get an average within about 10% of the appropriate size, which is 864,000 miles. So our sun is big. You can do this. I mean, you can actually do this anytime. It doesn't have to take an Eclipse. You can do this as a math exercise as a group. The kids can all grab their meter sticks and measure the distance from the mirror to the wall. You can have a couple of people measure the diameter of the image, and then you can all go back and work it out. And you can throw in an average. I mean, there's a lot of math that you can put into this that is, good for 5th graders. And they're all pretty proud usually when they get the right kind of number. I mean, they're not going to find it exact unless they're very, very lucky. But they should get fairly close. So anyway, so that can be done pretty much any time you have a sunny day, and you need to have I use my car, as you saw. That's because I don't have a cart, but you probably have access to a cart or something like this. You need some way of propping it up. I use towels. People I know have used things like bags of popcorn. Something that you can put the mirror propped up in there to where it's not going to move. If you try to hold it, I've done that before. If you take the mirror and try to hold it like this, I don't know about you, but it looks like there's something wrong with me medically, because it just isn't going to be consistent in terms of being able to measure the diameter of the thing, because it jumps around too much, because you need to get a long distance, and so it doesn't work too well. But a cart and a couple of things to prop it up with and to hold it in place works very well. So you probably aren't going to use this unless you except for yourself, for the Eclipse, but you can do this to say, hey kids, we're going to go do something different. We're going to measure the diameter of the sun. And they will go, huh? And you say, no, yeah, we'll do that. And usually that's different enough, and you say, oh, and by the way, we got to go outside. So and try to get your principal involved in it. Say that you got you're taking the yahoos outside, and you'd appreciate if the principal came along and kind of helped ride herd on things. Get the principal involved with doing things too. Okay, with that, we'll say thank you very much.
You want to explain what we're seeing?
Well, what we're looking at is the partial eclipse. The moon's moving in front of the sun, and I'm using the mirror method to make a fairly large image.
Almost, mentality, almost! Almost! Yeah!
We have liftoff.
Oh, that's a ring! Wow! Woo! Amazing!
Like I said,
Look straight up over there.
Just look
Yeah,
at
they're serious.
Yep.
Oh,
I think, there may be
Diamond ring. Diamond ring. Whoa, baby!